哦，OK，有怎么会？
共用你登出，本来都要重按一次共用。
重按一次共，等一下，那个
怎么了？
我因为已经是共同主持了，
不是，我是说那个画荧幕共分享，
还要再从头再分享一
它
次
共用内容登出，当然这个
应用。OK，好，各位同学早安。我们因为有20几位同学，这个确诊或者是这个隔离，所以我们现在就必须同时开这个视讯啊。同学们线上的都听得到吗？有人回答一下。
可以，
荧幕看得到吗？
可以，
教室里面的踊跃的同学看得到吗？有。好，OK，那我们就开始上课。And so now I switch from Mandarin to English. If I speak too fast or not clearly done, please raise your hand, okay? Or just let me know. Now we come into the content of material science. Material science and engineering, as I have told you yesterday, that we begin with atomic structure. The atomic structure here, maybe I should use atomic structure, and from atoms, the atoms will construct a crystal structure. Crystal structure is a periodic structure, 周期性的结构 and in 3D periodicity, 就是三维的这个周期性的结构。And then we could observe this atomic structure or microstructure with microscope. And there are different kinds of microscope. Optical microscope has a magnification around up to 1,000 times. And if we use electronic microscope, then the magnification will be more than 10,000 times or even higher than 100,000 times, so that we could see the very, very small, or we call that microstructure of a material. And we are dealing with quite a few content with microstructure of material. And then from the microscopic view, then we will see the macroscopic view. Macro, micro and macro, 微观跟宏观。So macroscopic 宏观的 and what is the macroscopic view? And for example, if you take a piece of steel and if you bend it, you find it's quite strong, it's quite hard. And if you have a piece of aluminum and if you bend it, and you will find it's pretty soft because you could bend the aluminum, but you could not bend the steel or ion. And that is the so-called macroscopic property, 宏观的这些性质. So that first we have the macroscopic property, and then we have to investigate the microstructure of that material so that we know why this material behaves hard or behaves soft. And then we have material property, and what I was just saying, soft or hard, and is exactly the material property. So then we could change material property by some specific processing, 一些特殊的制成. And we use, for example, there is a piece of steel. We could roll the steel under high temperature. 我们可以把一块钢板呢，在高温的时候呢，做混杂 so that the thickness of the steel reduces, and then the property also change. The more we roll the steel, the thinner the steel will be, and the harder also the steel will be, so that we could change the material property by process the material. And finally, you will find the performance of that material. So at the end, then you would like to, the material you have chosen to have a certain property or certain performance. And this is the way how we, from the beginning, from atomic structure to the performance of material. So that processing 叫做制成 different kind of processing 可以是机械的制成，可以是热的制成. As you learn something in the workshop in your first year, so that is also a kind of processing. 你在实习工厂做车烧加工、车洗报检，这也是一种processing. So that the processing then gives the material a specific shape or specific property here. And then from processing, and then we could change the structure, and then we'll have a certain property so that the material can have a certain performance which satisfies our need or satisfy our requirement on that material. Okay, so that this is the so-called core component of the discipline of material science and engineering and their interrelationship. So in material science or in material engineering, some people are focusing their research or their work on processing, how to process the material. And some people is interested in the structure of the material, to investigate atomic structure or to investigate the microstructure. And some people are conducting tests to obtain the property of the material. So you are going to have a material test in the third year, then you operate different kind of testing machine and to obtain the mechanical property of the material. For example, you could use hardness tester to achieve hardness of a material. You could use a tensile machine to obtain the tensile property of material. And performance. Some people are focusing on the performance of the material and how to make the material stronger and stronger. For example, earlier we do not have composite material, but nowadays we have a lot of composite material. Carbon fiber, 碳纤维, okay? Carbon fiber together with epoxy, and from that, then you could make, for example, a tennis racket or a bicycle frame and so on. That is the composite material, and people looking for new ways or some innovative idea to create or to invent a new material having new performance. Okay, and then I give you here. This is also an example in the textbook, and this is an
在放电子，已经没有电。
OK 没有电吗？
对。
Could you hear me at the back of the classroom？ 可以听得到我吗？OK。And I give you an example here, aluminum oxide, 氧化铝, and it could have the form of powder, or it could have the form of crystal, or it could have form of a mineral. Okay, so that with a different microstructure in the different microstructure of aluminum oxide, then give this aluminum oxide different shape or different properties. Here, what I show you is the optical property. Look at here, and this one, the left-hand side, this one is a single crystal of aluminum oxide. So aluminum oxide becomes a regular 3D periodic structure, so it becomes a crystal. And this crystal is very regular, so that there is only one crystal, and we call that only one crystal, a single crystal. And you could imagine in jewelry, 在珠宝店里面, you could buy a diamond, a piece of diamond or a small diamond. That is a single crystal. There is only one crystal. So single crystal is very expensive, but polycrystalline is not that expensive. Now you see here is a single crystal. The single crystal of aluminum oxide is completely transparent, like an gold. Then look at here, we have polycrystalline aluminum oxide. So then this is not completely transparent. It's called translucent. Sorry, we could see not the bottom part of this GPT because of that, which hides me from saying that word. But if you download my PowerPoint, then you will see that. So polycrystalline is a translucent fine folding. Now, if I use aluminum oxide powder and to sinter a piece of that block, then it becomes a polycrystalline porous structure. Porous, then it is not transparent. Okay, so different microstructures then induce different property, and here you see is the optical property. Okay, then we are going to talk about the material selection process. So how do you select a proper material for your specific application? For example, if you are an engineer in an automobile industry and you have to choose a material for a certain automobile shaft, 你要选择一个这个轮轴的这个材料，那你们应该要怎么选择呢？ So application, and you have to determine the application. So then first you have to determine the required property. What is the required property for a shaft? And the shaft must exhibit certain strengths. Okay, strength is the mechanical property. We have yielding strength or fracture strength. Yield strength 叫做相处强度. It means that material deform. If material deform, then it becomes useless, right? 一个汽车的轮轴如果变形了，它就不能用。So then you have the required property that is the yielding strength, 的降服强度。你外面受的力量不能超过材料的 相处它。So you have the property, okay? Then here mechanical. We were talking about mechanical property. Then in another course, strength of material, and you are also taking, that is 材料力学, right? So you are taking the course 材料力学. In 材料力学, then you learn how to calculate the stress because you have external loading. External loading, you have learned that in freshman course in statics and dynamics,在地力学跟动力学里面学到了如何来计算外力，对不对？把那个外力能够算出来。And then you apply the external force or external loading on the component, on that material. Then you have to calculate the stress applied on that material. Stress means the force divided by area. So then you have stress 应力 ，OK？ 那你算出了应力之后 then you compare the stress you have calculated with the yielding strength of that material. And if the applied stress exceeds the yielding strength, then it means that the material will fail. Then you could not use that material, right? You have to choose another material which is more stronger. Then it means that the yielding strength must be higher than the calculated strength. So this is the way how you determine the required property. So when you determine the required property, you need the knowledge not only in engineering material, you also need the knowledge in strength of material. Of course, you need to know the knowledge, what you have already learned. You could not forget it. So that is the statics dynamics, okay? So then we have, here we only talk about mechanical property. It could be also electric property, thermal property, and so on. Then once you have the property, and then you could identify the candidate material. So then you select a certain candidate. There are different candidates. You could use steel, you could use aluminum, you could use other metals. Then and what you have to consider, or what you have to take account is not only the mechanical property, and you have also consider the price, and you have to consider the economy, whether you use that material economically or which is too expensive to be used, and so on. Then material, then you have to look at the structure and also the composition. Composition means the 材料的这个成分. The different steel has different composition of alloy element. So if you put different alloy element in steel, of course not. You put the manufacturer put different element in steel, and it will yield different property. Then you have to choose the property. And third, then if you find the material and the material is good for this purpose, however, the strength is still not high enough, then you have to identify a certain required processing to make the material harder. So in this course, I will tell you some of the processing, including mechanical processing. Mechanical processing, 我们称为叫做机械加工. For example, I just mentioned rolling, 叫做滚炸或者叫做这个滚样, and it could give the material better property. Upon rolling, the material will become harder. So this is the processing. Or with thermal processing, 叫做热加工, or thermal or heat treatment, 叫做热处理. 我可以把这个材料加热冷却 and make the material harder or softer. So that is the processing. So during processing, the material change its structure and overall shape, okay? Either structure or shape or both. For example, casting 有听过 casting 叫做铸造吗？有听过啊？铸造就是把一个这个材料把它变成水，变成这个液体，然后把它铸到一个模子。So casting is actually the primitive processing of our ancestry. So in the ancient time, humans found ore, 找到了矿砂、矿土 and they put into the smelt furnace or blast furnace. And they found that upon heating to a very high temperature, then liquid flowing out from that ore. And that liquid then gradually solidified, become a metal. So our old ancient ancestry, and they have invented the casting process, 铸造的这个方法。Okay? And sintering process, sintering we call 烧结的方法。Sintering is to accumulate or make the powder, the metallic powder or ceramic powder into a solid block. 烧结就是把那种金属的粉末、陶瓷的粉末，把它聚在一起呢，就把它烧成这样的一块啊，这样的这个方法。And vapor deposition，叫做蒸镀啊，蒸镀的这个方法。We could coat a very thin sheet of material onto other material and to let the material have other properties. Maybe you use some a drill. 你的工厂就是有个钻头啊，the drill some drill looks shiny and looks with the gold color and such drill is coated with certain hard metal so that the surface of the drill becomes very hard so that the drill will not wear during braiding. And this is also the application of vapor deposition. And forming 就叫做成型。Okay, forming including rolling, what I just mentioned, or forging, 叫做锻造, or you just take a hammer and to hammer a certain metal block. And that is also a kind of forming. And welding, 叫做焊接, and you join two pieces of metal together with the electric arc, because the electric arc melts a part of the material, and so that the two parts of the material will be joined together. And this is the welding process or annealing. Annealing is kind of heat treatment. We are going to deal with that later, so I just skip that. So that you see from this block diagram, the structure of this course of the material science. And so I let you know, we begin from chapter 2, and we're going to talk about atoms, we're going to talk about electrons, and so on. And then from chapter 3, 4, 5, then I go from atoms to crystal, because I just mentioned that crystal is the periodic structure of atoms. So that we are going to study the crystal and the crystal structure, so that then in chapter 3, 4, 5, and then if we have already learned the structure, then you will find why the material behaves hard or why material behaves soft. And it is because of the structure. So we are going to learn the mechanical property in chapter 6. Okay, and in chapter 7, going here and look at here this word vocabulary, this defect. What is the defect? 缺陷. Okay, and crystal structure or periodic structure is a perfect structure, is an idealized structure. Just imagine that if this class is complete filled with students, there is no vacancies missing here in this classroom, and this classroom becomes a perfect classroom. Okay, but there are some missing side or uh, some missing seed here. Then, and all this missing side we call defect, 缺陷, and the missing big, and the missing side could be an atomic missing side, or it could be a block of atoms, and so on. So that we are going to learn the defect here. There are different defects. Vacancy 我们叫做空位，就是说少了一颗原子或者少了几颗原子。And dislocation 我们称之为叫做差态。So a row of atoms is mismatched, so that or the place becomes not correct, or twins or stacking fault and so on. So, and we are going to talk about that later in chapter 7. Then from this defect, there could be large defect, and we call that cracks. Cracks is okay, so material is not okay. Something wrong with the material. Material is not perfect, so that it could have a defect. Large defect becomes crack. If there's a crack in the material, would you use that material? No, right? So, and in chapter 8, we're dealing with cracks. And then in chapter 9, we're going to talk about the microstructure. And before we talk about microstructure, then I will give you knowledge regarding phases. 象. So we know there are 3 phases: solid phase, liquid phase, gaseous phase, right? 物象, 液象, 气象. And this is the 3 phases or 3 states of material. However, there are more than this 3 phases in metallic material, in ceramic material. There are different kind of phases. The phase, different phase looks different in microscope. And we're going to learn how to identify those phases. And if the phase change or if the phases change within microstructure, the mechanical property also change. And we do not have those knowledge. So that will be in chapter 9 or chapter 10. So, okay. So that in the textbook in chapter 10 to 11, we are dealing with casting, metal forming, or welding. But I'm afraid we don't have time for that. So I think for this semester, we will go to so far to phases and let you know and teach you how to identify some easy microstructure of steel. So that this is approximately the content of this semester, okay? Now, this is also a picture in the textbook, and give you an image regarding the relationship between structure, between processing, and mechanical property. So here, look at here, 碳钢的硬度跟显微组结构 or phases 跟它的这个像的这个关系。And here, vertical axis show you the hardness, 硬度, okay? The higher the number, the harder the material will be, okay? And then here, on the axis, you see the cooling rate. Cooling rate, it means that the cooling, the temperature, the cooling temperature per unit time per second. So 1,000, it means that so within 1 second, the temperature will decrease from 1,000 degrees to 0 degrees. So fast, okay? Very high cooling rate, very slow cooling rate. And here you see, if I put a piece of steel in into a furnace, and I heat steel from room temperature to a 1,000 degrees C, or even higher, 1,200 degrees C, so that the material is very hot and looks glow, as glow, okay? 会是热的，整个都发亮的。And suddenly you could test this very high temperature steel directly into water. And we call that, you just put it directly into then the cooling rate will be extremely fast, maybe reach within 2 seconds, and then from 1,200 degrees to room temperature. Okay, and you could also cool that material in a very slow way. For example, only 0.01 degree per second. It means that maybe you take the piece of steel out of the furnace and put it on a certain table and let it cool naturally. Then it will have quite low cooling temperature, or even you could let the material be put in the furnace, and you just open the door of the furnace and switch off the furnace, but you still put the steel in the furnace, and then it will have still slower cooling rate. So different cooling rate, and interestingly, after the material is cooled to room temperature, you could prepare a kind of specimen, and you could grind the specimen and investigate the material under microscope. So what you see here are microscopic images from optical microscope, and even this image from electronic microscope. 所以这些呢，就我们把这个材料在电子显微镜或在光学显微镜底下看到的这个影像，the same steel, the same block of steel, just under different cooling rate, and under different cooling rate means under different processing, 不同的制程。Then interestingly, you see completely different microstructure. Okay, looks like from different materials, but actually they all belong to the same material, only with different treatment. And this microstructure behaves very soft, and this microstructure behaves very hard. And one of the goals of the engineering material is to improve the material property so that the thermal treatment or the heat treatment is one of the important process in nowadays in the industry. And we have to learn the principle or the basic background of this kind of microstructure change. Okay, why study engineering material for mechanical engineers? Yeah, there are several reasons here. Yeah, we have to conduct machine design. Yeah, as a mechanical engineer, later on, if you are going to work in the industry and you have to design a certain machine or design a certain component. For example, one of my graduate students and told me many years ago, he graduated from the graduate school and then worked in a company called Jong-Ning, okay. And during that time, Jong-Ning also developed a cell phone, not smartphone at that time, 20 years ago. And they also developed a cell phone. And maybe when you were a child, then you could still remember a cell phone is still quite complicated, and you have to unfold the case, and you have to press that. Okay, and there are also cell phone sides folded. Okay, so there are a lot of uh, so mechanism on that cell。就以前的手机哈，跟手机有许多的设计的这个机构 machine design。And that student went to me one day and proudly say that, oh, hi, sir, look, now the one of type of the cell phone is quite famous in the market. Okay, 那个时候呢，宏基的手机有一款手机蛮有名的。And he told me that I'm the group leader of the design。他说我是这只手机的这个专案的这个负责人，所以等于说这只手机就是我设计出来的。And he was proud of that. Okay, so as mechanical engineer, and we may have to design some machine or design some component or design some product. Okay, so machine design, component design always involves material selection. So at the end, you have to calculate the stress, you have design the shape and so on. Then finally, you still have to determine what material you are going to use. And this is the basic knowledge of what you are going to learn here. So then materials mechanical property must match in service condition of machines and components. And so this is why you learn mechanics, okay? You learn statics, you learn dynamics, and now you learn strength of material. And this is the goal, and you have to match the mechanical property with the service condition. Service condition, external forces, external loading, and you have to calculate the reaction, you have to calculate the strength within a material. Then you match the calculated strength with the material property, compare with the material property. And this is what an engineering is going to do. So basic knowledge on relationship between microstructure and mechanical property, just as the previous slide showed you the microstructure and hardness. Okay. So case study, maybe during the course, I'm going to provide you some case study, interesting case study regarding the history of material application. For example, here, how could I remove? Yeah, okay. This is a ship broken into two during World War II. And here is the misuse of certain material of steel, so that it's quite dangerous. This ship broken into two in a harbor, so it's still on that. But then it's very dangerous or vulnerable if the ship is on the sea and suddenly it breaks into two, and it will lose property, it will lose lives, right? So, and this is our the goal of mechanical engineering, to learn a material. Now we are going to go into the topic of material. So classification of material, okay? Classification 分类. So basically, there are four kind of material or four category of material. The first one is metal, and the second one is ceramic. The third one is polymers, and the fourth is composite. Composite means the combination of all these three. Metals, steel, aluminum, all kind of metal, so you know, and ceramic. And more ceramics are applied in engineering or in advanced engineering material. 陶瓷材料. Yeah, ceramic material is very hard. However, ceramic material is brittle. What is brittle? Brittle means ceramic material is quite I could not write properly. Brittle. Okay, I write later because there's some problem with the writing. Brittle means 脆，知道这个字吗？brittle，知道就举手。知道，brittle, brittle means the material break easily. Okay, just like glass or ceramic or some pottery. So it's this kind of material is brittle, brittle but very hard. Nowadays we could improve ceramic material becomes very hard but not brittle, and then it has a lot of application in new technology. For example, in our car, usually you classify the car with the engine volume. Okay, no, we say a car with 1,300 cc or yeah, okay, or 2,000 cc or 3,000 cc. It means the larger the number, the larger the volume of the cylinder in the engine. But nowadays, we do not need engine with such large volume. We could use a small engine to save energy, save fuel. But in order to achieve the same power of with smaller engine, then maybe some of you may have already heard about the turbo. Anyone heard about turbo in car engine? 有听过吗？就是说这个汽车的引擎里面加了一个 turbo，这有听过的举手啊，应该有一些有听过。So nowadays, for example, I own a car only 1,400 cc, 1,400 cc, but with almost 160 horsepower. Okay, because that car has a turbo in the engine. So turbo, it means that to accelerate the air and the mixing of air with the fuel, so that the power could be increased with this turbo with 加上一个这个涡轮的这个叶片 and because the temperature of that the gas within engine is extremely high. If you use different kind of other material, even if you use metal, and it could not resist such temperature at long time. Okay, maybe short time, several seconds, several minutes. But if you drive a car, many hours, right? Many hours are running on the highway, so it must be temperature endurance, so that we use ceramic material, which use ceramic turbine, and 用陶瓷的这种涡轮的这个叶片 and so that it could resist high temperature. And this is one of the application of ceramic. Polymer 称之为高分子的材料。The polymer is actually so many plastic material, 塑胶材料 okay? Plastic material is the typical polymers. So nowadays we have many kind of plastic material. It becomes even big problem for the environment. Okay, so there are PE, PPT, so PPS and different P, right? P signifies or stands for polymer, okay, polymer, and we use many engineering plastic. You see your cell phone or your computer, the case of the computer, or even many computers have many components in a car, and plastic are widely used in those applications. So because plastic material is cheaper plastic material can be formed easily. There are different kind of material processing for plastic material. So plastic material is widely applied, okay, polymer. And then combination of these three, then we have composite. And look at this triangle, and it becomes a pyramid, okay? Look at here, metal, ceramic, and polymer. Three basic material, and then the combination of them then becomes composite here. And now the fourth corner is the so-called semiconductor. Actually, semiconductor 半导体材料 is a kind of mixture between metal and ceramic. It has property of metal. It has also property of ceramic. So that we also take semiconductor material as one of the material classification, so that you have a pyramid. 有一个金字塔在这个地方，金字塔的四个角落呢 ，metal, ceramic, polymers, and semiconductor. And in between, so combination of metals and ceramic is composite, or ceramic combined with polymer, also composite, and polymer with semiconductor, also composite. Composite 我们叫做复合材料啊，这几种的复合材料。And so we are going to in the first week or the second week, I'll also introduce you semiconductor and biomaterial 生物性的材料 ，functional material 功能性的材料 ，and smart material 智慧型的材料。Actually, the material is not smart. Human that provides the uniqueness of for some certain function and to this material, so that this material looks smart. OK， 就是有一些这个材料，哎，你进去碰它一下呢，你会触电哦。哦，就是说你碰它一下，它会发出电能来，这样子，就是看起来好像很 smart， 不是这个也还是我们人类赋予这些材料的功能啊。So all this kind of material we call advanced material. Okay, so advanced. But basically, on the background, we are going to focus still on metallic material, maybe a little bit regarding ceramic material. So let's do the basic structure of material. Okay. Okay, then I would like to take a break for 10 minutes. Okay, and then we start in 10 minutes again, and then you take a break. Okay. Okay, let's start again. 线上同学听得到吗 ？Hello， 线上同学听得到吗？
可以。
好，谢谢。好，来旁边的摇一下，大家很辛苦。Okay, we're going to go into detail of the category of material, and the first one is metals. Metals refers to metallic bonding. In chapter 2, we are going to deal with different kind of atomic bonding, 不同的金属、不同的原子的键结。但是现在先跟大家讲一下 metals is because that metal behave hard or metal behave electrical conductive. 金属会有导电性，对不对？metal behaves hard， 金属呢表现出是比较硬的，and it is partly because of the metallic bonding， 是因为有金属键的这个键结。And we are going to deal with that in chapter 2. So metal is strong, is ductile. Ductile 叫做粘性，所以基本上金属的粘性都是不错。Okay. And high thermal and electrical conductivity. So thermal conductivity, so we use metal as our cooking ware because we need a good thermal conductivity. And we use metal as electric wire, and we use, for example, copper, or even we use silver as, or sometimes with aluminum, and we use that as electric wire for very good thermal and for very good electrical conductivity. And metal is opaque. Opaque 是什么？是不透明的啊，是不透明。And the opposite is transparent. Okay, transparent. Reflective. Reflective 有反射性的。And shining 有金属光泽的。Okay, and this is metal. But what we need in mechanical engineering is that metal is strong and metal is ductile. And polymer, most of the plastic belongs to polymers or rubbers, natural polymer material, 橡胶 rubber. I just mentioned PE, PVC, PPT, and so on. Okay, and polymers has covalent bonding. Covalent bonding 叫做共价键 and covalent bonding, it means that atoms shares electrons with other atoms so that they build a covalent bonding and sharing of electrons. And polymers are typical as plastic materials, 塑胶材料呢, and they are soft, and they are ductile, and they have pretty or relative low strength, not as high as metallic material, and low density. Low density so that it is light, and some of them have density even lower than 1, so that many plastics can float on water. And then thermal and electrical insulators, so that we wrap or we cover the electric wire with polymers, with plastic. Okay, and we also use plastic as some thermal insulator. For example, your cooking pot and the hand grill that use plastic material to protect you from burning. Okay, and optically translucent or even transparent. So translucent 叫做半透明的 or transparent. Transparent is the completely the light comes through, goes through that material that is transparent. So the camera lens on your phone are all made of plastic material, not made of glass material, so that plastic material has a lot of wide range of application here. And then ceramic usually there could be ionic bonding, ionic 叫做离子键的这个键结。Ionic bonding is a very strong bonding because it is so strong, so that ceramic behaves also very strong and very hard. And this word refractory, what is refractory? 叫做耐火的。OK，所以很多这些炉子啊，这些炉衬啊，都是用这个陶瓷材料，用陶瓷材料，它才能够 refractory，能够耐火。It is because ionic bonding. Ionic bonding is so strong. So, ionic bonding consists of an ion and an anion， 是一个阳离子跟一个是阴离子这样结合在一起形成离子键。So that it is extremely strong. So then usually the bonding consists of metallic and non-metallic elements. For example, oxide, carbide, nitride, or sulfide. 很多的这些氧化物、碳化物、氮化物、硫化物，这些呢形成结合起来就变成了陶瓷材料。Just as one of the example I just show you, the aluminum oxide, 氧化铝 so that it's metallic material, aluminum, and non-metallic material, oxygen. Okay, they combine together becomes oxide, and oxide or carbide. Carbide is also extremely hard. So the tool you use in the lathe machine, that's 一年级在做车厂用的那个车刀，以前呢就是用金属车刀，你们用的车刀是一个小三角形在前面，那个小三角形通常现在都是 ceramic material. So, and ceramic material, it behaves brittle. Okay, this is brittle. I just show you brittle 叫做脆的 ，and glassy 就是像玻璃一样的。Okay, and behave elastic. So elastic 它的弹性是非常好，它的就是弹簧长处是非常的高的啊，是非常的高。你看它好像不会没有弹性，它其实是这个弹性的。And usually it's a very good material of insulator. It's non-conducting because it's ionic bonding. So all the shell, all the outer shell has completely occupied by electrons. So it's very, very stable so that it's also non-conducting. 它不会这个，就是它不会导电。然后呢，这个绝缘性也是非常的这个好。So then the composite is the combination between those three. So composed of two or more material of the upper category, so that for example, here we have carbon fiber reinforced polymer, CFRP. So FRP is fiber reinforced polymer, 叫做纤维强化的高分子材料，就是塑钢。各位可能有听过叫做塑钢啊，这就是玻璃纤维强化的。那现在呢，如果是用这个 carbon fiber reinforced， 用碳纤维强化的。那这个就变成什么？就变成现在的这个运动材料，像您的网球拍、羽球拍，多半都是 carbon fiber reinforced (CFRP). Also, bicycle frame, very expensive bicycle frame are frequently made of CFRP. So it has a combination of property of material, the combination property of the metal, polymer, and ceramic. And depend on, so best characterized or best characteristic of each of the component material. So, and the combined property exhibit the best property of each kind of material. For example, carbon fiber, carbon is extremely strong. If you make carbon into fiber, so it is extremely strong, and the property is directional， 就是说这个 carbon fiber 的话， 它会有方向性，所以你要特定的方向给它的这个强度很强哦。And then polymer is ductile, soft, and but polymer has a good property to combine, to join all the fibers together. So then we use polymer to join all the fiber together so that we have here fiber reinforced polymer. So summary, and metal, ceramics, and polymers, and they have this kind of unique property. So just for your reference then here. And then we have several charts here in our textbook. Here show you the density and then different material, metal, ceramic, polymer, and composite. Usually metal has highest density about all the kind of material. So, and then second to ceramic. Ceramic have a density usually second to metal. So during steel making or other metal making, usually the slag is floating on the liquid metal. So because of lower density comparing with metal， 所以一般在熔铁、在炼铁的时候的那些叫做 slag， 叫做矿渣，或者是这些铁渣，它都是浮在那个上面的，因为它是 ceramic material， 所以它的密度通常是比较低。And some polymer material may have density as low as 1, so that this material will float on water. And composite, so then depends on what kind of material you're using, you're combining, so that density lies in quite a wide range. And then we see here the stiffness. What is stiffness here? So stiffness we call actually so elastic modulus， 我们称之为叫做弹性的模量或者叫弹性的模数 ，exactly the spring constant, okay, spring constant 弹簧卡。But in material or in strength of material 材料力学we are talking about Young's modulus. Young's modulus, that is the elastic behavior between stress and strain. So elastic. If you apply the load and it bends, if you release the load, it will go back to its original shape, and we call that elastic. So the higher the elastic modulus or the higher the stiffness, the harder the material will be. Okay, and so metal, ceramic, both of them have very high stiffness, elastic constant. Okay, and then polymer is quite soft. So then you see here the log scale. Look at here is not the regular scale, it's the log scale, and it's pretty high for metal and ceramic, and for polymer it's quite low. And composite is the combination between them. And then the next property is strength. Strength 强度, okay? And we express that so in the scale of stress, that is force divided by area， 力量除以面积，那得到的我们称之为叫做 strength， 叫做强度，一个材料的这个 strength， 或者是我们称之为一个材料它能够抵抗的应力能够抵抗的应力到什么程度 ？And so here strength, and usually we talk about tensile strength 拉伸的这个强度，所以基本上我们这个工程材料在业界通常这个进来以后呢，都要验收。那么验收都是验收什么呢？验收说我的 tensile strength 有多少，或者我的 yielding strength 我的降服强度有多少啊？所以这些metals and ceramics they belong to the same category, and polymer far below, because here look at here again log scale, not regular scale. And then here, the resistance to fracture, Yes, this is a quite new concept. Usually, we only consider the strength of material. So that, yeah, I think everyone know. So glass, you know glass. Glass, you may say is the polymer material. Okay, no, it's ceramic material. Looks like ceramic material, but actually it's not ceramic material. But anyway, glass behaves very hard. It's very hard, right? But hard is not equal to high strength. Yes, high strength also. Yes, the strength is quite high, but you will not use glass as a mechanical shaft or some important component to resist loading, right? Why do you why don't you use glass as those material? Because glass is extremely brittle，极度的 brittle，就是非常的脆。Once you take a small stone and cast on the glass, it broke, it breaks, right? Why? Because glass cannot resist fracture. OK，就是这种玻璃呢，它不能阻挡什么 resistance of fracture。fracture 叫做这个断裂或者叫做这个破裂。And also ceramic is comparing to metal is quite poor in resisting fracture. Just like you use dishes and bowl and so on， 你用的盘子啦、碗啊，对不对？强度硬不硬？非常硬。它的强度很高，硬度也很低，但是你把它放在轻轻这样掉到地上，马上就破掉。So this kind of material cannot resist fracture. So fracture resistance become also a quite important property nowadays because some of the machine is under impact loading. Some of the machine is under impact loading. 有一些设备，有一些这个机器，它是受到这种冲击的这个负荷，它时常受到这个冲击的负荷，那它必须呢有非常好的 resistance against fracture. So metal has a very good resistance against fracture, and all other materials, ceramic, polymer, they are poor in resisting fracture. So that look at here also log scale, but composite. So you could combine metal with polymer, combine metal with ceramics and polymer, so that there is a wide range of fracture resistance. Okay. Okay, then we're going to talk about advanced material, and the first one is semiconductor. Okay, semiconductor from the periodic table. Yeah, maybe some of you have already forgotten periodic table, but please get the periodic table back. We still have something to say with the periodic table because yeah, the materials we are using belongs one or some of the elements in the periodic table. Now, semiconductor, most of the semiconductor material, for example, carbon, here, arsenide, and then tin, and so on. And this from 3, 4, 5, okay? And boron, aluminum, gallium, indium, and from 3 to 5, we call that so 3, 5. So 3A to 5A. Okay, 3A to 5. Maybe here 3, 4, 5, and some of the 6 here. Look at here. The white ones are metal, and the gray ones are no metal. No metal, mostly gas. Okay, gas inert gas or other kind of gas. But here, intermediate, it means so some behave like metal, some behave like non-metal. And then here are some elements behave intermediate. So these elements are all possible elements applied in semiconductor. And because most of the element of in semiconductor belongs to the third, fourth, and fifth category, so we call it 三五族, okay? 三五族. And you may frequently see this word 三五族 in newspaper. 三五族 stands for actually semiconductor. And you see, you usually read 三五族 in newspaper, not in the industry category, but in economical or financial category. Why? Because stock market, okay? 你在报纸上面看到这个三五族都不是在什么科技版，都是在什么呢？都是在股票版哦，股票版说哦三五族概念股，这个现在这个股价很高哦啊，这就是指这个 ，OK？ And biomaterial. So biomaterial is the material compatible to body tissue. Body tissue. You might have operated due to some illness or you have to operate it. So after operation, doctor will seal the wall with stew and thread, right? And then so in 1 week you have to let all this thread remove, 拆线. But more and more, there will be the tissue compatible material or tissue compatible thread. So you do not have to go back to hospital to remove all the thread because the thread is also biological compatible and becomes your tissue eventually. So that, but when it becomes your tissue, it's just like the kind of looks ugly. So people still go to the hospital and let the thread to be removed. But more and more, for some replacement in our inner organ, and there are different kind of biomaterial which is compatible. And smart material, usually we refer smart material as sensor or actuator. Sensor 叫做传感器啊 ，actuator 我们叫做制动器。And sensor and actuator is a very important part in automation. 在自动化的这个设备里面是非常重要的。You have to sense temperature. You have to sense force, sense stress, or sense vibration, or sense acceleration, and so on within a machine. When the sensor feel the impact force, and the machine has to be react some way directly. So then sensor receive signal from the outer impact, and this signal will transform into certain control algorithm. 所以这些呢，就是 sensor 叫传感器，它接收到一些讯号，对不对？这些讯号就要变成另外一种控制的这个语言，就回馈让这个系统产生一些反制的作用。So that the sensor receives signals, and this signal transform into control language, and this control language or control signal will actuate some component to react or to adjust, right? And to react or adjust, we call it actuator, 叫做制动器. So sensor on one side, actuator on the other side. Always, they are a opposite part, but both sensor and actuator, they receive signals, or they also send signals sometimes. Okay, and this is kind of smart material. And I will introduce you shape memory alloy, 叫做 形状记忆合金 and piezoelectric ceramic。piezo 这个叫做压电材料 ，piezo 叫做压的这个意思 ，and electric 电 ，OK ceramic and this piezo ceramic is exactly both sensor and actuator. Okay, and nowadays, more and more popular, we are using optical fiber for example, our web transmission and so on in your house or here in this building. We have replaced all the copper wire into optical fiber cable so that the data transmission will much more efficient and faster. And then we're talking about shortly we are talking about nanomaterial, nano 纳米材料. So it's quite it's quite famous or quite hot, right? So everyone are talking about so 纳米, and who knows what is nanomaterial? Actually, I let you know. I could say every material is actually nanomaterial because the diameter of an atom is about 10 to the minus 12 or 10 to the minus 13 meter. So it's in the nano range, and the nano size atoms then compose into a material. So that, however, we have nowadays nanomaterial because you may have nanoparticles, nanowire, and so nanofiber. Usually they have the size even smaller than 100 nanometer. 1 nanometer is 10 to the minus how much? Okay, 一个 nano 是10的多少？不知道，知道吗？知道的讲一声，来，10的负几？对，负9，负9 ，so small. Okay, so I think the rest of this will be talked next week. So, and should you have any problem with your health, or you are talking and please stay at home or stay at home. Just email me, okay? And then you will attend the conference. 好，我们今天就上课到这个地方。好。